If you have ever sat by the wing of a large commercial jet or observed the tips of the wings closely, you may have noticed an upturn in the wingtip or a special device attached to the tip of the wing. What exactly do these devices do, and why do they appear in different shapes and forms? If you have ever wondered about these devices, then stay tuned, because this is what we will be exploring in today's video. Welcome back. In this video, we will be delving into an interesting design aspect of an aircraft's wing. Now, before we dive into the purpose of those devices that we alluded to earlier, let's take a moment to understand one of the four basic forces that acts on an aircraft in flight, as this will provide some context. If you watched the video that explains how lift is generated, you might recall that one of the four forces acting on an aircraft in flight is drag, which is a resistance to motion. As a general rule, drag opposes thrust and acts rearward parallel to the relative wind. Drag acting on an aircraft in flight is primarily comprised of two types. We have parasite drag and induced drag. Now, in case you're wondering what these two types of drag are, very quickly, parasite drag is created because of the aircraft's structure itself and is not associated with the production of lift. In other words, it is a resistance that is encountered as a result of the airframe moving through a mass of air and encountering all those air molecules, which in turn pose the resistance. Now, let's explore induced drag in some detail, as this is the reason why aircraft wings have those structures on their wingtips. Induced drag is inherent whenever an airfoil or wing is producing lift. And in fact, this type of drag is inseparable from the production of lift. Consequently, it is always present when lift is produced. You see, an aircraft's wing is shaped to generate low pressure on the upper surface and high pressure on the lower surface as the aircraft moves forward. This unequal pressure creates lift across the upper surface, and the aircraft is able to leave the ground and fly. Unequal pressure, however, also causes air at each wingtip to flow outward along the lower surface and inboard along the upper surface, causing the air from the bottom to escape to the top. As remember, air flows from high pressure to low pressure. Now, this interaction of air that occurs around the wingtips produces a whirlwind of air called a vortex. A vortex is a counter-rotating tunnel of air that forms at the wingtips as the wing generates lift. The vortices are usually invisible, but on a very humid day, the central core of the vortex may become visible because the air pressure within its center has reduced sufficiently for condensation to occur. Now, by definition, the lift created by a wing is at right angles to the airflow. However, the interaction of the airflow between the top and the bottom of the wing leads to the creation of wingtip vortices, as we've already explored. And this results in a slight backward tilt in the lift vector. And this contributes to drag, and it's exactly what is induced drag. The word induced because it is a result of the generation of the lift force. Now let's circle back to what the devices on the wingtips are called and why they are installed, all against the backdrop of the phenomenon of induced drag. These devices are called winglets, and they are quite simply vertical extensions of the wingtips to improve an aircraft's aerodynamic efficiency and reduce fuel costs. The concept of the winglets was introduced in the 1970s when the price of aviation fuel began spiraling upward. As airlines and aircraft manufacturers looked at different ways to improve the operating efficiency of aircraft, winglets became one of the industry's most visible fuel-saving technologies, and their use continues to expand. Winglets increase an aircraft's operating efficiency by reducing the interaction of the airflow between the bottom and the top of the wing surface. Now, as this interaction is curtailed, which in turn diminishes the strength of the vortices, this contributes to a reduction in induced drag. As drag decreases, the aerodynamic efficiency of the wing increases. That translates into fuel savings. Throughout the aviation industry, winglets are responsible for increased mileage rates of as much as 7%. We have explored the fundamental working principle of a winglet. Not all aircraft types use winglets to help minimize induced drag, and they employ variations of it that essentially serve the same purpose. Just for example, the new Airbus 320s use something called sharklets as opposed to their older counterparts that use wingtip fences. The Boeing 777 and the 787 are a little bit unique as their wingtips do not see an upturn. Instead, they employ something called raked wingtips. Raked wingtips design is where the tip of the wing has a higher degree of sweep than the rest of the wing. Again, this design serves to achieve the purpose of reducing induced drag whilst optimizing cruise performance. Alright, so there we have it. We've explored one of the main devices that aircraft manufacturers incorporate in the design aspect of their wings to reduce aerodynamic drag. In addition to reducing induced drag, these devices also reduce wake turbulence by decreasing the strength of the wingtip vortices. Wake turbulence is a potentially serious hazard to other aircraft. It is also worth noting that there are several devices that aircraft employ to minimize drag in addition to winglets, such as fairings, as keeping drag to a minimum brings several benefits to airlines, such as reduced fuel burn and therefore cost savings and a smaller carbon footprint, a greater range, and so on. I hope that made some sense and it wasn't too difficult to follow. As always, if you have any questions or comments, or if you would like a certain topic related to aviation offline covered, please put that in the comments below and I will do my best to cover that in a future video. If you liked the video, please give it a thumbs up and share it along. Well, thanks very much for your time and support as always, and I look forward to seeing you in the next one again very soon. Thanks very much again, and I wish you a great day.